Definite integrals, part 9.
Hi, hello everyone. For this session, we will discuss new concept. So here, area under the curves. So let f of x be any curve. So here consider the coordinate axis. So this is x-axis and this is y-axis. Okay. So here let f of x be any curve. This is y is equals to f of x, and area under the curve f of x. So within the limits x is equals to a and x is equals to b and x-axis. So this area. So this is a sum. So clearly this area is what? That is integral a to b f of x dx. Okay. So this is the required area. So this means the area under the curve f of x. So within the limits a and b and x-axis. So see the first one. Let f from closed interval a comma b tends to 0 to infinity is continuous. So then the area bounded by the curve f of x, the x-axis and the lines x is equals to a and x is equals to b. So here suppose this is coordinate axis. So let y is equal to f of x be any curve, and the given lines are what? X is equals to a and x is equals to b. So clearly these lines are parallel to y-axis. So this is x is equals to a line and this is x is equals to b line. So clearly this area is what? So clearly this area bounded by the curve f of x and the lines x is equals to a and x is equals to b and x-axis. So therefore that area is given by integral a to b f of x dx. Suppose that is some b. Okay. So clearly in that case the graph lies above the x-axis. So here codomain values are closed 0 to infinity, positive values. So means the graph lies above the x-axis. Okay. And see the second case. So let f from closed interval a comma b tends to minus infinity comma 0 is continuous. So then the area bounded by the curve f of x, the x-axis and the lines x is equals to a comma x is equals to b is given by. So here f from closed interval a comma b tends to minus infinity comma 0. So clearly here codomain values are negative values. So in that case the graph lies below the x-axis. So see here like this. So this is the coordinate axis, x and y-axis. Suppose this is the curve y is equals to f of x and the lines are given, that is what? X is equals to a, x is equals to b. So clearly that lines are parallel to y-axis and x-axis. So clearly you want to find this area. So clearly this area is bounded by the curve f of x within the limits x is equals to a, x is equals to b and x-axis. So this area is given by a is equals to minus integral a to b f of x dx. So because of the graph lies below the x-axis, so in that case we have to write minus. Okay. So see the third one. Let f from closed interval a comma b tends to or be continuous and f of x values greater than or equals to 0 for all x belongs to closed interval a comma c, and f of x is less than or equals to 0 for all x belongs to closed interval c comma b. So here in this interval f of x values are positive and this interval f of x values are negative. So in that case, then the area bounded by the curve f of x, the x-axis and the lines x is equals to a comma x is equals to b is given by. So here consider the coordinate axis. This is x and y axis. So here the given interval is a comma b. Suppose this is a and this is b. Suppose c belongs to closed interval a comma b. And see here in this interval a comma c, f of x is greater than or equals to 0. So means the graph lies above the x-axis. But in this interval c to b, f of x is less than or equals to 0. So clearly the graph lies below the x-axis. So therefore the graph crosses the x-axis. So like this. X is equals to a and x is equals to b. So clearly see here in this interval a comma c, the graph lies above the x-axis. So clear this curve is what? Y is equals to f of x. And between the interval c to b, so clearly see here the graph lies below the x-axis. So therefore the required area is, that is a is equals to integral a to c. So in this interval the graph lies above the x-axis. So clearly write f of x dx. But in this interval c to b, the graph lies below the x-axis. So we have to write minus. So minus integral c to b f of x dx. So this is the required area. So here note, let f of x be any curve. Okay. See here f from closed interval a comma b tends to r. Suppose let c belongs to closed interval a comma b. So here, so consider the coordinate axis. This is x and y axis. Suppose y is equal to f of x be any curve crosses the x axis. So like this. So within the interval a to b, okay. Suppose the graph crosses the x-axis at x is equal to c. Now clearly see here. So what is this area and this area? So therefore the required area is what? A is equals to integral a to c. So in this interval the graph lies above the x-axis. So write f of x dx. And in this interval c to b, the graph lies below the x-axis. So write minus integral c to b f of x dx. So for example, this length, distance between a and c, some k. And here distance between c and b also k. So means the distance between a and c and b are equal. So clearly in that case c is the midpoint of a and b. So in that case the required area can be written as 2 times of integral a to c f of x dx, or 2 times of integral c to b f of x dx. Okay. So here we have to take modulus. So because of area is positive only. Okay. So see the fourth one. Let f from closed interval a comma b tends to r and g from closed interval a comma b tends to r be continuous functions in closed interval a comma b. So see our first one. If f of x is less than or equals to g of x, so for all x belongs to closed interval a comma b, so then the area bounded by the curve f of x comma g of x, the x-axis and lines x is equals to a comma x is equals to b is, so see here f from a to b tends to r and g from a to b tends to r be any two continuous functions. So here consider the coordinate axis. This is x and y axis. So for example, this is y is equal to f of x and this is y is equals to g of x. So be any two curves. Then area bounded by the curve f of x and the lines x is equals to a comma x is equals to b. So this is the area bounded by the curve f of x and the lines x is equals to a, x is equals to b and x axis. And again the area bounded by the curve g of x and the line x is equals to a and x is equals to b. This total area. Okay. So but here f of x is less than or equals to g of x for all x belongs to closed interval a comma b. So in that case the area is this area. Okay. Now here you need to find the area of this. So clear here f of x is less than or equals to g of x. So in that case the area bounded by the curve f of x g of x, f of x g of x and the lines x is equals to a, x is equals to b and x axis is given by a is equals to, see here, integral a to b. See here f of x is less than or equal to g of x. So in that case we have to write g of x first minus f of x dx. So this is what integral a to b g of x dx minus integral a to b f of x dx. So this is the area under the curves f of x g of x and the lines x is equals to a, x is equals to b, x axis. So this area. Okay. So this is the first case. And see the second case, f of x is greater than or equal to g of x. In that case the area bounded by the curves f of x g of x, x axis x is equals to a, x is equals to b is what? Integral a to b. See here f of x is greater than or equal to g of x. So then you have to write f of x first minus g of x dx. So this is the required area, that is integral a to b f of x dx minus integral a to b g of x dx. So in that case the given graph like this. This is x axis, y axis. Okay. So this is the curve y is equals to f of x and this curve y is equals to g of x. Now you need to find area bounded by the curve f of x and g of x. So this area. So within the limits x is equals to a and x is equals to b and x axis is what? Integral a to b f of x dx minus integral a to b g of x dx. So see the fifth one. Let f and g are two continuous function in the interval a comma b and c belongs to open interval a comma b. So see the first one. So here f of x is less than g of x for all x belongs to a to c. And second one, g of x is less than f of x for all x belongs to c to b. So then the area or the required area is given by. So here consider the coordinate axis. This is x and y axis. Here the two curves are what? Y is equal to f of x and y is equal to g of x. Suppose these two curves crosses at point C. Okay. Now here f of x is less than g of x. So in that case this is f of x and this is g of x. So interval is what? A to B. So clearly in the interval A to C, f of x is less than g of x. So see here in the interval A to C, so clearly f of x is less than g of x. So you need to find this area. And in the interval C to B, see here g of x is less than f of x. So clearly now, so this is g of x, this is f of x. So clearly in that interval g of x is less than f of x. Therefore the required area, so this area is what? A is equals to, see here, integral A to C. See here clearly f of x is less than g of x. So write g of x minus f of x dx. Next, plus integral C to B. So in this interval g of x is less than f of x. So we have to write f of x minus g of x dx. So this is the required area. The sixth one, let f from closed interval a comma b tends to positive 0 to infinity is continuous. Okay, in the interval a comma b. So then the area bounded by the curve f of y, the y-axis and the lines y is equals to a comma y is equals to b is, so here consider the coordinate axis. This is x and y axis. Okay. So clearly here positive values, codomain values are. So let consider any curve. The curve is what? X is equals to g of y. So that curve lies to the right of y axis and the area bounded by the curve g of y and the lines y is equals to a, y is equals to b, y axis. So this area. So clearly that area is a is equals to integral a to b. So clearly the graph lies to the right of y axis. So clearly positive only. So write f of y dy. So see the seventh one. Let f from a to b tends to minus infinity comma 0. So here values are negative and it is continuous in the interval a comma b. Then the area bounded by the curve f of y axis and the line y is equals to a, y is equals to b is. So here consider the coordinate axis. This is x and y axis. Okay. Now here codomain values are negative values. So for that consider x is equals to f of y be any curve to the left of y axis. Then the area bounded by the curve f of y and the lines y is equals to a, y is equals to b, y axis. So this area. So clearly that area is what? Integral a to b. So see here the graph lies to the left of y axis. So clearly negative. And write f of y dy. So this is the required area. So see the eighth one. Let f and g are continuous in the interval a comma b. So and f of y is greater than or is equals to g of y for all y belongs to closed interval a comma b. So then the required area is, so here consider the coordinate axis. This is x and y axis. So here this is the curve, x is equals to f of y, and this is the curve, x is equals to g of y. So see here clearly f of y is greater than or equals to g of y. So within the interval y is equals to a, y is equals to b. So this area. So clearly this is the required area, and that area is bounded by the curve f of y and g of y axis, and the lines y is equals to a, y is equals to b is a is equals to integral a to b. So this can be written as, so see here f of y is greater than or equals to g of y. So write f of y first minus g of y dy. So this is the required area. See here for example second one, f of y is less than or equals to g of y. So in that case the required area is what? Integral a to b. So here g of y is greater, therefore g of y write first. So g of y minus f of y dy. So this is the required area. So here for all y belongs to closed interval a comma b. So for next session we will discuss more problems.